Hey friends, we are working on writing equations of lines again. I'm getting yesterday's notes videoed here, but we are just bringing in Thursday's information of slopes of lines with writing equations of lines. But we need to review all those things in order to bring them together. Remember the three forms of lines. Our first one's standard. We don't do anything with this but to change it to this form or change this form into another one. And that's ax plus by equals c. Remember, a, b, and c are integers, and a is positive. Alright, and then an example of this would be something like 5x minus 3y is equal to 15. It lets us know here the coefficients. Notice there are no decimals. A is positive. It's not the best form. In fact, it's probably my least favorite form. And then the form that I think everyone should use the most would be point slope, because it even takes the place of the slope intercept form, because it always works. You just need a point on the line and the slope of the line. And that's y minus y1 equals m times the quantity x minus x1. M equals the slope, and x1, y1 is any point, I should say any point on the line, and it works. An example of this would be something like y minus 3 equals a negative 2 times the quantity x plus 5, where your slope is going to be a negative 2, and your point comes out the opposites. Remember, this is x1 and this is y1. So this would be a negative 5, positive 3. So we should be able to plug it in and be able to pull it out. And the other one is our slope-intercept form, and it only works for one specific scenario, and so I don't like it, to be honest with you. I like it for working with calculators, so I changed it into the form of slope y-intercept, which is y equals mx plus b, where m equals the slope and b is the y coordinate. Oops, spelled coordinate there. Y coordinate of the y-intercept, which would be 0, b. So an example of this you all know is like negative 2x plus 5. Your slope is a negative 2. Your ordered pair would be 0, 5 for your intercept. Now, a few things we also need to remember. Slopes of parallel lines. Remember, parallel lines have the same slant. That means the slopes are the same. They're equal. So if I know one, I know the other. Slopes of perpendicular lines. Remember, vertical and horizontal lines are also perpendicular. They are opposite reciprocals. Some examples of this would be like, if my slope is a negative 4, my opposite reciprocal would be a positive 1/4. Or if my slope is a negative 7/3, my opposite reciprocal is a positive 3/7. So those are just some examples of perpendicular line slopes. Now, on this page, we're going to sit there and use that to figure out some of our information. Like, for instance, here's what we're going to use. It says, write an equation for the line that is parallel to line AB that contains point C. So I have a point, and right away, notice that's not the y-intercept. You know you're going to have to use point slope form. But I'm missing the slope. But I still have key hints to help me out, because it says the lines are parallel. So I look back up here and I go, oh, that means their slopes are the same. So if I know the slope of line AB, I know the slope. So the slope of line AB, because it's in slope-intercept form, I'll use subscript here, is 2/3. The slope of the line parallel to it would also be 2/3. So here's my slope, here's my point. And I just plug it into point slope form. So y minus y1, which is 5, equals 2/3 times the quantity x minus 3. I didn't say to change forms or anything like that, so you just leave it in that form. Now the next one, I want to write an equation for the line that is perpendicular to line AB this time. So it contains point C. So I still have another point. This is going to be my x1, y1. But I still need a slope. Well, my slope for line AB stayed the same. It's 2/3. But I want a line that's perpendicular to it. So I go up here and go, okay, slopes of perpendicular lines are opposite reciprocals. So if this is 2/3, the slope of the line that's perpendicular to it is a negative 3/2. So then we plug our points in. So we get y minus y1 equals m times the quantity x minus x1, plugging into our point slope form because I have a point and a slope. So we go y minus y1, which is 1, equals our slope, which is a negative 3/2, times the quantity x minus, oh look, that's a negative 3, so I put parentheses around it, and then I rewrite this one little step. Some of you can skip. Some of you are very good. You go from here to here, and that's totally okay if you don't lose track of your negative signs. All right, and let's do last example on this page. It says write an equation for the line that goes through 5, -7, and is perpendicular to the x-axis. So let's just do a quick graph of this. Here is my coordinate axis, my x and my y. I have 5, -7 is somewhere down here. Now I have an equation of a line that is going to be perpendicular to the x-axis. So what type of line would that be? A vertical line. So when I have a vertical line, what type of slope do I have? The slope is undefined. Well, that means you have to use your notes from the other day that we talked about how to find a vertical line. Now, here's the hint. Remember, when you have a vertical line, it hits the x-axis, and the x never changes. So really, my x-intercept is over here at 5, 0. So when I do that, all I ever have to do to write the equation of a vertical line is to go x is equal to whatever your x coordinate is in your ordered pair. So x equals 5. And that would be your vertical line. Pretty cool.